Hello everyone, this is Lexinen, and today I'd like to show you all kinds of amazing things you can do with circuits, devices, and contraptions in the Sandbox Evolution. We'll start out with the basics, and work our way up to some demonstration contraptions by the end of the video. So, let's jump right in. In the Sandbox Evolution, you build circuits using the metal element, which conducts electricity in the form of the electro element. You can make wires out of a line of metal that is 1 pixel wide. When an electrode touches the top of the metal wire, it will begin traveling through the wire. Wires don't always have to be straight. You can change the path of the electrode using a bend shaped like this. I recommend always rounding the corners of the wires like this. Square corners can sometimes act up. You can also connect multiple wires together. If an electrode finds a fork in the circuit, it will split into 2 electrodes, each following a branch of the circuit. What happens to an electrode once it reaches the end of a wire? Well, if the end is exposed to air, the electrode will jump out of the wire into the air. If the end is blocked, though, the electrode will disappear. Similarly, if 2 electrodes collide within a wire, they will cancel each other out the same way. Each circuit you build will have 3 parts: the input, which is the source of the circuit's electrodes, the output, which is what the electrodes will power, and the routing, which connects the input to the output so that electrodes can travel through the circuit. The way that you build each part depends on what you want the circuit to do. Sometimes the layout will be simple, like this, while other times it will be more complex. Knowing how to build complex circuits like this takes time and practice, but the method of building them is no different than for a simple circuit: input, output, and routing. Let's talk about some of the elements that will be useful for building circuits. You can find most of these under the Technology or Light tabs. The battery is a simple device that provides a constant stream of electrodes. It is one of the most basic input elements. You can adjust the timing of the battery by tapping and holding on the battery, then selecting a speed from this dialog. The lower the number, the faster the electrodes will come. The E-battery works similarly, but you can change the timing by sending 2 electrodes to it. The flip-flop is another source of electrodes that can be toggled on or off, like this. For more interactive inputs, you can use sensors. You'll find these under the Light tab, and each one generates an electro when a certain condition is met. The one you will likely use the most is the human sensor. Simply put, if a human comes close to one, it makes 1 electro. You can think of it like a button. The lever works similarly, except it toggles a stream of electrodes on and off instead. There are all kinds of other sensors too. Some can detect cold, or heat, or liquids, or the time of day, or even lasers. Of course, you need something to power with your circuits too. These are your outputs. For example, the E-gate opens when touching an electrified wire and closes otherwise. Similarly, the E-heater heats up when powered. The E-cooler cools down, bulbs and LEDs turn on, the E laser fires, and so on. If an element has an E prefix, it can usually be used as a circuit output. Two special E elements that find a lot of use in circuits are the E multi and E drain. E multi is the powered version of the multi-element. It will latch onto the first element it touches, then replicate it each time an electrode passes through an adjacent wire. E-drain can drain away any liquids or gases that touch it. Each electrode will toggle the drain open or closed. Finally, let's talk about routing elements. You can use these to control how the electrodes travel from input to output. The resistor is one of the most useful ones. A resistor will absorb every other electrode, cutting in half the number of electrodes that pass through the wire. The fuse is also quite useful. Once an electrode passes through, it will explode, preventing any more electrodes from passing through the wire. Lastly, there's crosswire, which allows you to cross wires over each other without mixing up their electrodes. Time to make some contraptions with these elements. Again, let's start with some basic arrangements and work our way up. Forming the metal like this, we can make a diode. Electrodes can only flow in the direction the diode is pointing. If we add a layer of metal to the diode, we can make a buffer, which puts out a stream of electrodes if one goes into the input. Since electrodes can jump out of exposed wires, we can use a gap of error in our circuits too. This one acts much like a diode, except that electrodes bounce off of the output rather than disappearing. Air gaps can also be used to join two inputs together without splitting the electrodes. If we arrange two gaps as shown here, we can make an electrode bounce between them. Connecting another wire as an output, you can make a stream of electrodes with timing determined by the lengths of the two legs. We can combine an air gap with an E multi or E drain like this to make a transmission gate. When the gap is clear, electrodes can flow through the circuit like this. When the gap is filled with a liquid or gas, though, no electrodes can go through. You can use the E multi and E drain to fill and drain the gate as needed to control the flow of electricity. Another way to make a transmission gate is to arrange an E drain and E multi like this. The E multi generates a pixel of acid with each electrode. The acid can flow through only if the drain is closed, so you can toggle this gate on and off by toggling the state of the drain. We can chain gates together in different ways to make logic gates. For example, electrodes can only go through this circuit if both gates are clear. Timers and counters can be made with an E multi and liquid sensor arranged like this. Each incoming electrode fills the column with a little bit of liquid, triggering the sensor once the liquid reaches that height. We can even harness the random elements of the game in our circuits. For example, liquid pixels shift randomly left and right when they hit a solid pixel. We can use this fact to drive a random output with drops of acid, or randomize the timing of a stream of electrodes. Electrodes also randomly shift left and right while floating in the air, so we can make a sort of random resistor like this. That's it for now. Hopefully you've enjoyed this video and learned a thing or two about circuits too. With practice, you can make fantastic creations with your own circuits too.